right, I'm a bit late, but I apologize for that. There's one trick to do with these modern high-resolution screens, and when you're projecting, is to actually change the resolution so you can all see it, rather than just me. So my name is Julian Bucknall. I'm the CTO of DevExpress. We've got a booth over there, and I'm here to talk about Breaking Bad, and you can make secure, fast web pages. So when we navigate to a web page, we have certain expectations that the page renders quickly. In other words, we're not sitting there just staring at a blank screen, wondering whether our internet connection has gone down yet again. And then we can get whatever information the page is providing quickly, whatever information or task that the page is providing. In fact, that's one way of looking at web pages. A page is basically a conduit for a set of user tasks. It could be a news site, for example, in which case our task is to gather at a glance the top news stories of the day and to drill down if something catches our eye. It could be a search engine like Google or Bing. So the task at hand is similar. We want to scan and select. It could be just an article on a subject we're interested in. The quicker we can start reading it, the better. We don't really care about the CSS loading and all the nice adverts that are coming in. We just want to start reading the article. So, where have I put it? There we are. So it's all about perceived performance. It's how to ensure the user's experience with your web page or with your web application enables them to complete their task or task as quickly as possible. It's all about the perceived performance, not necessarily the raw performance. It's what the user experiences, not necessarily what your profiler is telling you. And this talk is going to be about breaking bad in the sense of breaking your bad habits, not necessarily pushing you over onto the dark side. So for that to happen, two main aspects must come together. The first one is the design and the content of the page, information on the page. And the second one is the raw speed, the technical speed, how fast things are downloading, how quickly things are being rendered, whether the display freezes or not. Now, I'm sure for a lot of people here, I'm going to guess, the first aspect is a little frightening, the design and the content. A super designer, I am not. We at DevExpress employ a large number of UI designers and graphics designers, and I'm glad, because I'm a developer. So how do you present the information needed for your user's task in a nicely visible, succinct, legible manner as possible? It's all about grouping text and imagery, typographic choices, of dreaded white space. It's about creating that experience that will reward your regular users and also try and reward your new readers as well. So it's a black art. So let's just assume somebody in a Armani sweater has designed us the layout and the content, and as developers, let's concentrate on improving the speed of the code, improving the speed of the rendering of perceived performance. Now, before we jump off, no matter how performant a page is in a technical sense, the speed is, again, I'm going to bang on about this, it's perceived by the end user. It's not perceived by the number of milliseconds it took to display some resource on the page. Now, one of the things, I don't know, let's have a hands up here. How many people have been to see Star Tours at Walt Disney World? Anybody? Or even Walt Disneyland? I think there's one in there as well. It's a great little ride, I must say. The nice thing about Star Tours is, at one point in the ride, and it was a long time ago that I actually did this, so at one point in the ride, you're all in this Star Speeder craft, and there's a droid in front who's steering you to take you on a little trip around the asteroids or something. And at one point, he basically goes through a set of doors and you drop. Now, the screen showing you the drop and the fact that the whole craft is just tipping slightly makes you believe, you perceiving that there's a huge vertical drop and you're sliding down this well. In reality, the angle is nowhere near 90 degrees. The ride basically is fooling your perception, making you believe something that isn't true. And to a large extent, website performance is exactly the same way. You're going to be fooling your end users that the site is more performant than it is. So, web performance of lifestyles. Oh, I forgot this bit. We can measure how quickly the browser downloads the various files and renders them, but in the end, it's all about perceived performance. We need to concentrate then on what the user expects for the time to completion of the task, not necessarily what you can time it as. Now, as an example, what I'm going to do is to jump over to Amazon.com. I'm sure you've all been to Amazon.com. Amazon's developers have elevated this concept of the user's subjective view of the web page versus the actual objective speed of the web page. And I'm going to make a pun here. They've basically made it performance art. They are incredible. Now, let me just switch over to, well, I've got Firefox over here somewhere. And here's the Amazon front page. And as I refresh it, you see what kind of happens is, the central part stays the same, and the rest of it kind of builds around it. Of course, when I've done this talk in the past, it's never been the same look and feel and all the rest of it. What I want you to show you now is, I'm just going to basically jump over, and that's not what I wanted to do. Oh, come on, heck. Okay, what I want you to do is to look at damn it, Janet, is to look at the scroll bar. I'm going to refresh the page now. I was trying to zoom it in, but it doesn't look like my, yes, let me load my Zoom program. That's why it's the problem. I apologize, I had to reboot before I started this, so. Let me just load my Zoom program. There we go. Okay. So, let's look at the scroll bar as I refresh this page. First thing you'll notice, let me get out of this. Oh, there you go. It's very quick. But you notice the scroll bar was pretty much full size, and then it shrank. What actually happened there is the page is loading above the fold first. In other words, what you see on the front page there, and then it loads the rest. And it's a two-step process. Above the fold is first of all downloaded and rendered. And then while you're looking at that, while the user is looking at that, because in theory, the user is basically looking the fold, above the fold stuff because they want to go over to the navigation bar on the left, or they want to type something in the search bar. They're not really interested in what's below this thing. I don't really know what is below this thing. Jeff Bezos is trying to sell us something else. So it loads above the fold and then down below the fold. So bear that in mind. It's a kind of, the user is perceiving the site to be fast, no matter how much of this extra advertising and imagery and all the rest of it is being downloaded. According to the user, who's not paying attention to the scroll bar, the site is loaded extremely quickly. Google.com does it in a different way. Google.com is basically very, very lightweight. when you go to google.com, and the only thing you have is basically a text box, and they've been adding other stuff on, but it's around 40K for the markup on Google, whereas the markup on Amazon is huge. So let's jump back to my slides. Okay. Now, there have been studies on web response times showing that taking longer than a few seconds means the user will tend to leave and not come back, especially if you're on an e-commerce site. If you don't have the content up in front of the user within a couple of seconds, you're going to lose them, period. One study is Jacob Nielsen's article on the subject, and on website response times. Jacob Nielsen has been doing studies on UI for computers for a very long time, and basically he's talking about the response times limits, and I've got a better view of this. So around 0.1 of a second response time, the user thinks it's instantaneous. To quote Nielsen here, the outcome feels like it was caused by the user, not the computer. This level of responsiveness is essential to support the feeling of direct manipulation. That is, if you like, at this order of magnitude, it feels like the browser is directly responding to you, the user. Now, around 1 second response time, so we're doing magnitude changes here. Around 1 second, the user is aware something's happening. The browser is doing something, or the network is introducing some level of latency, but the train of thought is not being broken. To quote Nielsen again, users still feel in control of the overall experience, and that they're moving freely rather than waiting on the computer. Now, one level of magnitude higher, at 10 seconds, you've lost your user. The user has to really, really, really want to see your page. Nielsen again, they start thinking about other things, making it harder to get their brains back on track once the computer finally does respond. Now, how many times have you abandoned a site just because it was taking too long? Now, instead of hand waving, let's take a look at a real web page. This is a site that I use for my classic car. It's a Volvo 1800S, and it's 50 years old this year. We'll use the developer tools built in any modern browser. I'm going to use Firefox because that's what I'm used to. And I basically learned all this stuff with Firefox, and Firebug, in fact. Now, Firefox shows some effects on navigating that maybe Chrome doesn't so much. So this is my simple blog. So we'll jump over. Here it is. And I've made some changes to it so we can have a look at, quote, bad coding practices and how to improve those practices. I'm going to start up Firebug. And we're going to have a look at the net page, and I'm going to reload the site. So let it do its stuff. Now, the main thing to notice about this network display is that it shows a waterfall. Yes, cool. It's a waterfall. Big wait for the actual HTML, then lots of little stuff happening, and then more stuff happening, and so on and so on and so forth. The timeline progresses towards the right. The blue line represents an event when the DOM content has been loaded. So this blue line, and then the red line is essentially when the load event is fired. There's a kind of interesting couple of points. You can't really see very much of this. Let me just jump into my Zoom facility again. And so over here, there's a kind of delay. We take 100 milliseconds to receive it, then there's a little delay before something happens. and then we start downloading other stuff, and it's pretty quick at downloading. Thank God I'm using a wired connection here rather than wireless. And so on and so forth. There's another bit that's kind of interesting. If you look carefully, the files are batched in bunches of 6. There's 6 files here. If I go down a little bit, whoops, do it on the ground here. Bum, 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 bum. Oh, look, there's another 6 files. So 6 files, 6 files. The browser essentially, whoops, went too far. And here we go again. There's another 6 files, and there's another 6 files, and so on. So let's explain the gaps first of all. The first gap is kind of simple. The server has generated the HTML, the browser has downloaded it, and now starts parsing it to basically start creating the document object model. It does that essentially as it's downloading it, but the speed of download is fast enough that there is this break. And we basically start off by, there's the HTML, downloading a Google font, a couple of, more than a couple of CSS files, and then the jQuery is loaded, and then lots of JavaScript files. This is not an optimized site, I hasten to add. And the 6 at a time thing is, it's kind of server and browser dependent. In essence, the browser is trying to be nice to the server and only download 6 things at once. So it's a kind of a convention, if you like, to avoid overloading those stress servers out there. And they're trying to obviously service as many clients as possible. But let's say, assume for sake of argument that it takes, I don't know, about 200 milliseconds to download a particular resource. If the page markup, this page markup defines some 50 resources to download between images and JavaScript and CSS. If we're downloading in batches of 6, it's going to take around 2 seconds just to download the resources. So, big thought. So, first of all then, the downloading 6 at a time, well, why don't we just use lots of servers? Is the first idea. Bring out that. If we can only download 6 at a time from a given host name, let's have lots of host names with all of our content spread out across all of those host names. Kind of makes sense. The technique is known as domain sharding. So if I manage to store my content for this particular site on, say, 9 different host names, I speed it up, presumably. Yes and no. Another issue kind of creeps in here. For each new host name, we have to basically resolve the address. So we have to do a DNS lookup to find the IP address, and that takes time as well. 9 DNS lookups will take probably just as long as downloading 6 at a time from one site. So the sharding recommendation or is generally thought of is just use 3 host names at the maximum. Any more than that, you're going to be wasting time on the user side and also wasting your time as well, because you have to basically populate these host names with your content, your resources. So let's say 3 host names is the main host where the HTML is found. Oops. Yeah, the main host for the markup. Maybe a content delivery network for your JavaScript files, especially if you're using something like jQuery, Angular, any of those. And maybe a host on the cloud somewhere for your images. So you're using the cloud provider is better network connectivity than maybe your server has, for example. So 3 host names, that's pretty good. It's easy to split everything up as well. it's also easier to organize, as I said. What else can we do to reduce all this basic download time? Well, one obvious thing is to basically reduce the number of files. With 50 files, what are we going to do? Simple way of doing this is to concatenate files, especially with regard to JavaScript, but also CSS. I, for that particular site, bought a theme from Theme Forest, I think it was. And the theme comes with a gazillion JavaScript and a gazillion CSS files, and I've done nothing about it. I could basically concatenate them to make one CSS file if I really want to go that far, and one JavaScript file. So creating one master JavaScript file containing all the JavaScript for a particular website is one way to go. It can be done as part of a build process, for example. I wouldn't advocate loading up your editor and concatenating more manually. Sounds great. There are some gotchas. There's the caching issue. Caching issue, what I mean by that is with things like jQuery and jQuery UI or whatever, they're standard JavaScript files. And they'll be cached in your browser, presumably because of other websites that are using them. And if you start concatenating everything to one JavaScript file, then the browser has to go and find it. So you'll be trading the convenience, speed of caching with this 1 mega JavaScript file. And you'd basically force everyone to download it. There's the sharing issue. Nobody else will use this JavaScript file. You have to just get it from your site. And there's the expiry issue. Oh, have I just built it again? In which case everyone has to download it again. And then there's the strict mode problem. The strict mode problem. These days, writing JavaScript, we're encouraged to use the use strict pragma in our code. This tells the browser, tells the interpreter to use strict mode whilst interpreting and compiling the JavaScript. What strict mode is, it basically catches some common coding bloopers, throwing some exceptions. It prevents or throws errors on unsafe actions, such as gaining access to the global object. Creating a new variable on the global object is bad news. So you have to kind of jump through a little hoop in strict mode to get to the global object. And it disables some JavaScript features which are confusing and poorly thought out. Sounds good, we all say. We all like nice, clean JavaScript. There are two ways of applying use strict. One is the whole file. You put it right at the top of the file. It's just a string declaration. It's just a fancy string. And that's what you might call global strict mode. And then you do it per function if you want to do it per function. So you give the function declaration, then use strict is the first line in the function, and that function is only the one which is strictly interpreted. Now the issue with creating concatenated JavaScript is if I have a JavaScript file which is use strict, and then another JavaScript file which is not use strict, and then another JavaScript file which is use strict, the file in the middle is going to be using use strict anyway. And you're going to be altering the behavior of your application just because you've concatenated your JavaScript together. So you may find that the unconcatenated JavaScript works fine, but the concatenated stuff does not. So my advice, if you're going to do the concatenation thing and you do use strict, is to test it. Test it without, test it with. Does it have the same behavior? And then when you've done that, you test it again. And then every build you test it. You either do that or you make sure all of your JavaScript is use strict safe.
Okay.
Yeah?
Could you also have each wrapped in its own immediately invoked function?
Yes, you could do that way as well. Yes. No.
No, if you've made your
strict mode global,
then it doesn't matter. Right. Then you would have to also do it in each file. You would enable it per file in those files that you knew could work with these.
Okay.
True.
So anything else?
Another obvious one, minification.
It's an obvious step.
If you're using
CDN, for example, there's generally two versions of the JavaScript file for you to use. Quick debugging version, and there's the minified version. So the very least, what minification does, without going into too much detail, it removes unneeded white space. It renames internal identifiers to a shorter name. So A and B and C. Minifiers tend to be very good at doing that. Some minifiers
do some function rewriting, but this is pretty good.
As an example I've got here, I looked at jQuery 1.11. The debug version is 200%, and the minified version is 95K, a third as large. So minification can be good, especially if you have a site with a lot of JavaScript. Now there are many minifier apps out there. There's JSMin, which is the granddaddy of them all, written by Doug Crockford. I don't know anybody who actually uses it because the art tends to be a little better. I actually use one because the company I work for does Microsoft.net, something called Ajax Min, and also does JavaScript, CSS as well as JavaScript. Okay. Image optimization. Another way of reducing the amount of resources you're downloading. Image optimization is one of those things that not many people do unless it's their job to do it. The very first optimization to do, and a lot of CMS type applications do this for you, is to add image width and height or your image tags. By doing so, you're basically telling the browser the image is going to be this big, reserve this space until you actually get the image, and then the browser can just slot the image in. If you don't do this, then it reserves probably the size of the image not found icon, and when your image actually does arrive, it has to reshuffle the entire page. And remember, what we're doing here is to improve the user experience through perceived performance. And reordering and re-rendering the page just because you didn't put an image height and width in the user will see that as bad performance. With regard to JPEGs, there ain't a lot you can do. JPEG is a lossy compression format, and all you can basically do is reduce the image quality. It just makes them a little fuzzier. It's doable. So instead of 95% image quality, tone it down to about 70% and see what happens. Many photos you can't even tell. A lot of the photo has a lot of detail in it. Then you'll see the detail disappear. But that's essentially all you can do with JPEGs. Pings are a lot better. Ping files are lossless compressed. It uses a version of the zip compression format, deflate. So the way deflate works is it's a sliding window technique. Basically, looks ahead to see whether it's already seen a bunch of bytes in its buffer. If it's seen a bunch of bytes in the buffer, it just basically replaces those bunch of bytes with a pointer back to where they occurred before. Now, the problem with this
it
depends on how far
how much buffer you have, and so on and so forth.
The deflate
compression algorithm is essentially tunable.
Zip
itself doesn't tune very well. It's supposed to work with a whole bunch of files,
so it doesn't try and
do anything special for any of those files.
Deflate.
The underlying compression algorithm, you basically have a bunch of knobs, if you like, and you
twiddle around with them
until you get the best compression ratio.
And the best algorithm I found for ping files is known as ping out. Open source project. There's a commercial version for Windows, which is what I'm showing here. Basically, it's a multipass algorithm just for ping files. It just tries different tuned compression configurations to try and get the best compression ratio. It's a lossless compression, so the best compression ratio means essentially the smaller. But it would just keep on trying. I think it tries 6 times or something like that. And as we see here on this particular example, which I was doing on my machine, we've reduced something by, that's 2/3 the size of the original ping, and it looks exactly the same. So in essence, you're trading a longer time at the compression stage for a much reduced file size. Now, the final optimizer, well, it's actually not the final one, it's the last one, the optimization step, is equally as simple as all of these. It's placing your script tags at the end of the body element instead of in the traditional place, which is in the head element. The reason for this is simple enough. The browser, when it reaches a script tag and it's downloaded, will stop passing the markup and then start executing the JavaScript. So in my example, where I had 20 JavaScript files, or whatever it was, all these JavaScript files over here. Essentially, it's downloading them, and then at this point here, it has to start executing them. So there's another gap. Nothing much is happening
as far as the user is concerned.
It has downloaded all these files. It's got to stop creating the DOM. It's got to execute these JavaScript files. And by putting them as late as possible, this is what this site looks like. It's a CRM, so ignore the fancy schmancy HTML. So basically, I have a bunch of scripts that I'm downloading in the middle of the head. So nothing's been displayed to the end user at this point, because it's going to have to download all of these JavaScript files and execute them all, and then it will continue creating the DOM for the actual visible part of the web page. So by putting all these into the body rather than the head, you give your end user a more responsive page, even though the page is not working as it should. There's a great site by Steve Souders. Where are we? Which shows this in spades. What I'm going to do is show you this particular site here. The two iframes here. There's the iframe on the right, the scripts on the bottom, and then there's the iframe and there's the scripts. It's the server basically deliberately waits 10 seconds before returning the JavaScript. So let me just refresh that. So yeah, me as the user can start this page. I can actually read this iframe. Here I can't read a thing. I've gone. Too late. That's by the way, that's a great site. Wonderful. So that's another way of the performance is the same.
The performance is the same.
By the time the pages,
By the time the pages or the have actually fully rendered and fully finished
parsing and all the rest of it.
The same time has
gone by, but
the
one on the right,
the one on the right is much easier to
use.
The user is not aware that something is really happening.
Get worried about the fact
that you doesn't have any
images and all the rest of it.
images and all the rest of it.
So no matter what the how the script takes a long time to download
or whatever it is, the user is still able to use the right-hand side.
So, question, is that inside body or outside HTML?
It's inside body, right?
It's inside body, right at the end, before the slash body tag.
So don't place script tags.
Place script tags in the head.
Place them at the end of the body.
Place them at the end of the body, just before the end tag. And that's the place to go.
There's one more, which is
a fairly modern
invention because browsers support it. But these days, providing you're using a late Firefox, any Chrome, i.e. 8 or above, I believe, is think about async. What async says to the browser is, download me, but don't execute me straight away. You can just continue parsing the markup. I don't care. This particular bit of JavaScript is not going to affect. It's not going to add extra markup in or anything like that. So it's a way of. It's already downloaded asynchronously anyway, but it's a way of telling the browser that it shouldn't wait for this particular JavaScript file to be downloaded. So it's loading JavaScript asynchronously, or rather executing asynchronously. And the big problem with it is the browser will get round to it, but it doesn't do it in order. It's no guarantee that your JavaScript files, just because they're ordered 1, 2, 3, are actually going to get executed 1, 2, 3. It's possibly a big problem. If you're using jQuery, for example, and then you have some other JavaScript files which require jQuery to be there, you can't load jQuery asynchronously. Now, with the concatenation example, you can get away with it. Essentially. Because you're going to be creating this big file, full of your JavaScript, and it's going to get executed in sync. But there's just one file. There are various libraries out there. One called Require.js, which basically allows you to. There's one JavaScript file which gets loaded and executed automatically. Basically, it downloads all of your other JavaScript files and executes them in the order you define. So Require.js is a good one. So kind of grounding in all this up is, I want to get across the point that performance is subjective. Yeah, we can improve technical speed. But it's really about improving the perceived performance of your web page or web app. Yeah, great. Pay attention to render time and so on and so forth. Let's just as a rule of thumb here. Let's assume that 20% of the time is spent downloading resources. If I go back to my example. It's an awful lot happening here. Oops. An awful lot happening here. The actual download time of all these things is fairly short. The perceived performance of the page is going to be about how much is actually displayed to the end user and so on. So let's assume 20% of the time downloading resource files, shrink our resource files, reduce the number of resource files we're going to download, and so on and so forth. But the rest of the time is spent rendering. So it's worth spending that extra time. You're going to have more of a bang for your buck if you spend a lot of time on the rendering of
the actual information on your page.
So, to recap,
optimize your caching,
minimize the number of round trips, minimize download payloads, optimize the rendering,
where you should spend much time,
and
do a lot of testing.
Thank you. Oh, quicker recap. Oh yeah, web performance is like
Important thing is how the user perceives the performance.
Thank you.